Okay, for this problem, we are looking to find the temperature or the time the temperature reaches a certain temperature. So let's see. Outside temperature over the day can be modeled using a sinusoidal function. Suppose you know the temperature varies between 69 degrees and 101 degrees during the day, and the average temperature, daily temperature, first occurs at 10 a.m. How many hours after midnight to 2 decimal places does the temperature first reach 81 degrees? So what I did, I started filling this in. I know that my lowest temperature is 69, my highest temperature is 101, and the middle there is 85. I found that calculation here. So that's going to be actually our shift of the function. So that center line should be at 0, but it's going to be at 85 instead. Okay, a lot of little pieces to fill in here. Now, when I'm doing this model, it does say that it hits the 10 a.m. is going to be that average temperature. That's where it's hitting the center line. And so I decided to go with a cosine, which is still a sinusoidal, but a shifted sine function, a cosine curve, just so that I could have it start at an extreme point, in this case, the low point. Normally, cosines start high. This is going to start low, goes to a peak of 101, and comes back down again. Now, just to think about a day, which is 24 hours, if it hits that peak at 10 a.m., then it's going to hit that, not the peak, that mid temperature at 10 a.m., so 12 hours later, it's going to hit at 10 p.m. And that leaves it there the 12 hours of the day, a 24-hour day, 24-hour cycle we're talking about here, so 24-hour period. So that this must be 6 hours, and that this must be 6 hours. So if I go back 6 hours, that from 10 a.m., it's 4 a.m. So what I'm looking for is the time it's going to be at 81 degrees. So I have 81 here. So that's actually going to be somewhere before 10 a.m. that we're after. So let's go ahead and take a look at what we can come up with. Now, a couple other things we are going to look at would be the amplitude here. And our amplitude, let's think about what we have. We have 101 minus 69. That's going to be, let's do this little mathy here. 11 minus 9 is 2. That's a 9. 9 minus 6 is 3. So if I divide 32 by 2, we get 16. So it's 16 degrees above that center line and 16 degrees below that center line. So that means our A is going to be 16. And the fact that it starts down low, down here at the bottom end, and goes up and comes back down, we're going to go with a negative 16. So we can start seeing this function, this temperature function T of little t, is going to be negative 16 times cosine of bx plus c. So that's what we have to come up with next, plus 85. So we're already at 85 degrees. That's the average. That's the middle temperature. So that's why it's shifting up there. I already mentioned that. So let's talk about the bx plus c. Now, I do want to point one thing out. I know we're starting here at 4 a.m., but so it's not really shifted, though, because that's why I'm making that the bottom of the temperature. So we're really looking at the time past 4 a.m. So we'll add something to 4, because 4 is already the time past midnight. So I'm going to go with our c being 0, because it's see, the graph's not shifted horizontally, just the vertical shifting. It is reflected negatively, so that's why it starts at the bottom, but it's not shifted vertically. So let's look at this B. So when we do the B, we have a day is 24 hours. That's our period. And so the period is 2 pi divided by B. So that means I have B over 2 pi equals 1 over 24. So B would be equal to 2 pi over 24, or pi over 12. So now we're getting this function to look something like T of little t is going to be, I used an X, not a T, oops. That is my mistake there. And that should be a T up here as well. t of little t is negative 16 times cosine of pi over 12 times b plus the 85. So let's go from here now. We want to know when it's going to be 81. Oh, that shouldn't be a b, that should be a t. Okay, so we're going to have negative 16 cosine of pi over 12 times t plus 85 equals 81. So we're going to first subtract the 85. We have negative 16 cosine of pi over 12 times t equals negative 4. Then we can divide by negative 16. We have cosine of pi over 12 times t equals 1/4. Keep that in parentheses. Not that we need to, but anyway. So that means pi over 12 times t equals cosine inverse of 1/4. Okay, so let me get on my handy dandy calculator. And what is cosine inverse of 1/4? I get pi over 12 times t equals 1.31811. So I multiply both sides by 12 over pi. T would be 5.0348. So that's how many hours after it hit the bottom. So hours after it hit the low. The low is at 4 a.m. So add 4 to this, and 5 plus 4 is 9.0348 a.m. So I think that they were saying, scroll back up, I think it said it was going to be at how many hours after midnight, so rounded 2 places, so I'd say 9.03. Okay, that's it.